Delighting is the removal of original light and shadow from the source photogrammetry. In this tutorial, you'll learn how to import and configure your data in order to delight it. Before we begin, ensure that you're using linear color space by going to Edit, Project Settings, Player. In the inspector, choose Other Settings, then choose Linear from the Color Space drop-down menu. Now we're ready to launch the tool, so go to Window, Delighting Tool. As noted in the tool viewport, you can drag and drop a folder that contains your data. This is the most efficient way to use the tool. So first, we create a folder with the name of the data that we wish to delight. Right-click in the project view and choose Create New Folder. Next, we bring in our data. We right-click and select Import New Asset. Then we pick the textures required for delighting: the ambient occlusion map, the world normal map, the world bent normal map, and obviously the color map. Take care to make sure that the alpha channel of the color map is properly edited. This is used to exclude the background. It should be black on the background and white on the baked pixels. If the alpha channel is not properly edited, the result of the process will be greatly diminished. Unity will then import these maps using default settings. Now let's drag and drop the whole folder into the tool's viewport. Note that nothing happens here, and that the tool is offering a warning in the tool inspector, saying that the textures are still missing. That's because the textures don't respect the right naming convention. We have added this requirement in order to automate the import settings for you. If you switch the editor viewing mode to advanced, you can find in the import settings section that this tells you the naming conventions that you need. Let's rename the textures to match these conventions. You can see that the import settings by default are sRGB, and that textures are compressed, and that their maximum size is 2K. However, when I rename this normal map, you can see in the inspector that the correct settings are applied. I'm going to go through and apply these conventions to each file as appropriate, and drag my folder back into the viewport once I'm done. This time, all the textures have been correctly used, and all the lighting has automatically been removed from the color texture. You can compare before and after delighting by holding the left mouse button in the viewport and dragging the dividing line from left to right. Note that each texture can also be dropped individually into the texture fields, and the result will be automatically processed if the auto update button is turned on. Now we can see that there are some strange bright colors in the result, so let's take a closer look. To pan the view, drag with the middle mouse button held down. To zoom in or out, scroll the mouse wheel. If we look at the original image, we can see that there are badly reconstructed parts. This often happens when there are too few photos of this area or if it is very dark. To help resolve this, we need to create a mask to exclude these parts from the light measurement process. Open the color texture in a 2D editor such as Photoshop. In the badly reconstructed parts, roughly fill the area with red to create a mask. By doing this, these parts will be excluded from the light measurement process. Repeat the same process for each badly reconstructed part. Next, we fill the background with black and then save the texture with the _mask suffix. Because the texture respects the tool's naming conventions, it is automatically imported with the correct settings to act as a mask. Now you can drop this mask into the mask texture field on the tool. The result is instantly updated and you can see it solved the problem. But on one part of the texture, we can see there are still strange colors. This is because there was some black paint on the original rock. It is a very different material than the rest of the rock, and it can affect the light measurement too, so it should be excluded as well. We will open the mask in our 2D editor again, select the black paint area, and fill in the selection with red. We save the texture and return to Unity. The mask is re-imported, and we simply press the Compute button to update the result. Now the light removal seems to be good. If you've used color charts to correct pictures used for photogrammetry, you can use the color chart direction as a white light direction reference. To do this, toggle on the Reference Zone button. You can see that moving the zone changes the luminance and colour of the result. If you switch the view mode to debug, the reconstructed environment lighting is displayed in the inspector. The red dot shows the direction that the reference zone points at. This will be used to white balance the extracted lighting, and the result will be a much more accurate albedo. Click and drag on the gizmo circle to change the zone to an appropriate size. If you toggle on and off the reference zone button, you can see that there is not a big difference. That's because in this case, the automatic white balance of the tool worked pretty well. The albedo texture is now ready to be saved. Press the Export button and save it to the location of your choice. The default location is in the same folder as the original lit texture. Let's check the result when applied to a 3D mesh. Right-click and select Import New Asset. Select the mesh you used during texture baking, in our case, the rock we want to texture. Then, place it in a scene. If you are starting with this tool, add a plane too. It will help to check the lighting later. Now let's set up a test of this exported texture. Click on the rock and go to the Material section in the inspector. Set the albedo color to white. Choose an unlit texture shader. Drag and drop your original lit texture into the Material texture field. And now replace the original texture with the result of the light removal process. This is just a simple method to check your result directly within Unity. But it seems that the result is not perfect here. We can see an artifact along a UV seam. When there is discontinuity on UV seams, it is recommended to use a position map. The position map is a texture that can be baked by a variety of baking software, such as Substance Designer or Nold. When imported and renamed with the _position suffix, the texture can be dropped into the Position Map texture field. It fixes the problem that we spotted, and even some others that were more subtle. Now we export the texture again, overwriting our last attempt, and check the result in the scene. The artifact has disappeared. Now let's change the material to standard. The albedo color should still be white. Then we'll import the tangent space normal map that you should have baked with the other maps. This isn't a texture used for delighting, so there are no automatic import settings for it. You must manually set it as a normal map and change the texture size and compression parameters yourself. We drag and drop this normal map into the dedicated material slot, modify the smoothness, and drop in the ambient occlusion map as well. Finally, we'll select the plane and the rock and set them to be static geometry using the checkbox at the top of the inspector. This way, Unity will automatically bake the global illumination for both of these meshes. With the bake complete, you should see that the rock receives some extra indirect lighting from the ground. If we had used the original color map as an albedo, we can see that the dark parts would stay dark and the bright parts would have been too bright. This concludes our basic tutorial on using the delighting tool. For more information on using this tool, please see the links below for further documentation. Don't hesitate to look at it to discover the most advanced features of using this tool. Thanks for watching.